Okay, we're back looking at capacitance for this part of the lab. Currently looking in front of you, there's a series circuit set up. We have a voltage source here, uh, 4 cells, 6 volts. Starting on this end, we have the lamp, we have a compass, a capacitor, another lamp. This goes back to the back side of our battery here, so that's our series circuit. You can see that the circuit's open right now. And the purpose of it being open is that we want to look at 3 different states of this circuitry. The first one is when I close this circuit, we're going to look at the charging aspect of this capacitor. And then I'm going to leave it closed and we're going to look at what is the capacity of the circuit current while the capacitor is fully charged or partially fully charged. And then we're going to discharge the capacitor and we're going to look at the status of the current while we discharge it. So there'll be 3 different phases of this part of the lab. And then as indicators, we have 3 things set up. First, we have a bulb set up here, a lamp, that we want to see what happens during those phases to that bulb. Second, we have a compass set up, and so we'll see what happens to the status of that compass, which is parallel to the wire at this point. And third, we have a voltmeter set up. So there are 3 indicators to help us understand basically what's happening in the circuit during those 3 phases. So first thing I wanted to do was let's look at our voltage across this capacitor before we get started. And you can see that we're reading 0 volts on that. So we have a discharge capacitor. And the next step is let's go ahead and charge it and look at what happens to our light bulb and our compass. And I'm going to warn you that this happens very quickly, so you're probably going to have to look at the bulb and then come back, rewind the video, and look at the compass at the same time in order to see exactly what's going on there. But let's go ahead and charge this, watching the bulb in 3, 2, 1, charge. And that blink is just the amount of time that you get to see the voltage source charge that capacitor. I've now hooked it up. So this is a closed circuit. Um, it also deflected the compass counterclockwise at the exact moment that the bulb's lit up. And once the bulb cut out, the compass went back to normal. Let's go ahead and check the voltage across the capacitor at this point. So we'll look at the voltmeter there. And you can see that now we have about 6 volts, which is the same voltage as the cells over here. So we have literally no potential difference from this side of the circuit to this side of the circuit. And the components are in between those 2 devices. So there is no potential difference. Essentially, without a potential difference, there's no current flow between the 2. That might explain why current flowed while this was charging, but once this stopped charging, essentially the current stopped flowing, and it acts like an open circuit. There's no flow of current, there's no bulbs lit up or compass deflection. So this is the second status. While it's charged, we have no current flow. And so we'll look at the last status, and that is the discharging of a capacitor. So what I'm going to do for that is I'm going to go ahead and unconnect this, and now we have an open circuit. And while it's open, I'm going to go ahead and take a look at the voltage across here, and it does say 6 volts still. So even though we've disconnected from the voltage source, we still have 6 volts of capacitance. And now I'm going to short circuit this across these leads here. And when I do that, I want you to watch the bulb. 3, 2, 1. And that little blink right there is discharging the capacitor. And again, the bulbs went out just after a momentary blink. If you had watched the compass would have deflected clockwise. So that would be opposite of what happened when we charged it. Okay, and I think the last thing we should do here is we'll check the capacitance with the voltmeter, and we're back to 0 volts across the capacitor, so we're discharged. All right, that's essentially the things that we should be learning out of part three here about capacitors and how they operate within a series circuit. I might also mention that this is a DC voltage setup, and turns out that if we use AC voltage, things act just a little bit differently than they do when they're DC volts. So it'd be interesting to maybe explore that a little bit further and see how does all this react with AC voltage. All right, thank you.